Hello, we're going to differentiate tan or tan x or tan theta, whatever it comes in. Okay, first of all, we need to introduce a new function, a new word for you, and it's called a secant. Okay, so but we often call it just sec. Now, the definition of sec is sec theta or sec x or whatever variable you're using is 1 over cos. Okay, so sec x is 1 over cos x. Sec theta is 1 over cos theta. Now, also need to remember, in the same way we say sine squared theta means sine theta all squared. Okay, in that same way, sec squared theta means sec theta all squared. So we've got to remember that. Because the derivative of tan x is sec squared x. Okay, so there it is. The derivative of tan x here is sec squared x. So following that, in the same way that we've done the sine and cos questions before, let's have a look at what we would do if it was a tan of some function. Okay, we would go, the derivative of tan x is sec squared x. So whatever the function is, we have to put that there. And then we have to multiply by the derivative of whatever that function bit is there. The derivative, I'll just write that as f dash x. And we usually would write the derivative first and then write the sec squared and rewrite the function in there. Okay, so that's how we do differentiate tan. So let's have a look at some examples. Let's do these ones. Okay, if I'm going to differentiate tan 7x, tan goes to sec squared. We use the same function that we have in the thing, but then we need to multiply by the derivative of this bit. What's the derivative of 7x? Just 7. And so a lot of people would have just written this straight away, like sec squared of 7x. You can put brackets there if you want to make it look a bit clearer. Okay, what about this other one over here? I'm going to move over a little bit to make a bit of room. Okay, we still have tan of some function of x there. We have to worry about that. But to begin with, we just write the whole thing as it is. So the derivative, y dx, we just write it as, but we write, rather than writing tan, we write sec squared of that bit of underlined in green, just in the same way. But what do we need to do? We need to multiply by the derivative of this bit, okay? So what's the derivative of that bit? The derivative of 2x squared plus 3 is 4x, okay? And then we would normally bring that together, bring the 3 with the 4x together at the front. So we make 3 4s are 12x sec squared, and then write the bit there the same as we have before. Okay, so what about if we get something more complicated? Now this question comes out of your text, okay? This is using information that you've done before, along with the new information about tan. So let me just put over to the side. What did we do if I had y equals ln of, say, x squared plus 1? Okay, the derivative, remember for a log, you write the function bit here, just whatever it is, underneath the denominator, and on the top, you put the derivative of that function bit. So what's the derivative of x squared plus 1? It's 2x. So if you remember that, we're going to apply the same rule over here on the question. Okay, so this one, derivative. So we've got that minus, we just need to leave that there. But it's minus of ln of tan x. So what do? We need the function as it is, here it is as it is, written on the bottom. That means we just put tan x on the bottom. And what goes on the top is the derivative of this bit. Okay, what's the derivative of that bit? Tan x, the derivative is sec squared x. So then we've got that. Now, I wouldn't think the back of your book will have that. It'll actually simplify things a bit. And this one is one that you can simplify. But you've got to remember a couple of things. So over here, I'm just going to write to the side, remembering what we just said, that sec x is 1 on cos x. Okay, we just learnt that one. And the other one that you already know but might have forgotten is tan x is sine x over cos x. So remembering those two bits of information, let's go back over here and go over this. So this question is now, it's sec squared x. I'm going to write it with the divide symbol because I know when I divide a fraction, I have to, if I want to times it, I have to turn the second fraction upside down. So before I get to that bit, let's write this as I know it. Sec squared x. So sec is the same as cos. So it's actually 1 over cos squared x. Let's write the question as it is. And tan x, I can rewrite as sine x over cos x. So the questions, I've just rewritten it knowing those changes. Now, what do I know about when I'm dividing fractions? I can write the fraction as it times it by the reciprocal. Remember, I've got to turn the second bit upside down. Okay, so then what do I get? Well, look, I've got a cos x on top, and I've got a cos squared x down there. Okay, that means it's like I've got an x on top and an x squared down there. One of those goes all together. Excuse me, with one of those. And so what am I left with? -1 across the top, and on the bottom, I have cos x times sine x. Now that is absolutely fine, but for whatever reason in maths, we usually write the sine x first and then the cos x. And I think that'll be the answer. Sorry about that. A little scribble at the end. -1 over sine x times cos x. That's it.